Assalamu alaikum, my dear students. Welcome to your chemistry class of Standard 9. Hope all of you are very well and doing your work regularly and sincerely. We are in chapter 7, and in my first class I have discussed about different types of reaction on the basis of direction of reaction and heat change of reaction. Similarly, on the basis of electron transfer, reactions are again two types: redox reaction and non-redox reaction. Today, I will mainly discuss about redox reactions. In redox reaction, oxidation number is playing the most role. And most important role. You can say oxidation number is the heart of redox reaction. So at first you have to know about oxidation number. That means you have or you need a clear conception about oxidation number. So at first I will discuss about oxidation number. The number of electrons which an atom tends to give up or gain in a chemical reaction is called oxidation number. That means we know that in a chemical reaction actually bond formation occur. New bond is formed through the breaking of old bond. So, and also we know that from my previous chapters, also you know that in bonding, atoms are either releases electron or accepts electron or sharing electrons. So oxidation number is the number of that electron which are actually released or accepted or shared. That means which are transferred. So that number of electrons is called oxidation number. There are some rules for assigning oxidation numbers, such as the cation is written first in a formula. That means when you write a formula of compound, then at first you have to write positively charged part and then negatively charged part. For example, sodium hydride. You know that sodium is positively charged atom and hydrogen is in that sense negatively charged atom. Again, hydrogen chloride, both are non-metal. So since here hydrogen is firstly positioned, so here hydrogen is positively charged atom and chlorine is negatively charged atom. So whose position is first? That is actually cation, or we can say positively charged ion or atom, positively charged ion, that is cation, is written first in a formula. Now the oxidation number of a free element is always 0. Free element means elementary molecule. We know that molecules are two types, elementary molecule and compound molecule. So elementary molecule, here the oxidation number of that atoms of that molecule is always 0. For example, helium, its oxidation number 0. Nitrogen, similarly hydrogen, oxygen, chlorine, fluorine, bromine, iodine, all elementary molecule and their oxidation number is always considered 0. Now the oxidation number of a monoatomic ion equals to the charge of the ion. That means when any ion, monoatomic ion means only one atom is present, so their charge is equal to their oxidation number. For example, sodium ion, Na plus 1, so its oxidation number is plus 1. N3 minus, nitride ion, so its oxidation number is also minus 3. Then the usual oxidation number of hydrogen is plus 1 except in metal hydride. That means generally hydrogen when formed form bond with non-metal, then its oxidation number is always +1. But when it form compound with metal, in that cases its oxidation number will be -1. For example, in sodium hydride or any metallic hydride. Now, fluorine halogen atom, its oxidation number is always -1. Then also oxygen. In case of oxygen, when oxygen combine with any non-metal or metal, always or generally its oxidation number is -2. But in case of peroxides, for example hydrogen peroxide, calcium peroxide, sodium peroxide, in that cases oxidation number of oxygen is -1. And in case of superoxide, for example potassium superoxide, hydrogen superoxide, in these cases oxidation number is always -1/2. Now the sum of the oxidation numbers of all of the atoms in a neutral compound is 0. That means the sum of oxidation number of all atoms in a compound is equal to 0. For example, hydrogen chloride, hydrogen +1, chlorine -1 equal to 0. Like this, calcium oxide, calcium +2, oxygen -2 is equal to 0. Now another rules is the sum of the oxidation number in a polyatomic ion is equal to the charge of the ion. That means in case of radicals, radicals are actually polyatomic ion. For example, sulfate. Here more than one atom is present. For this they are called polyatomic ion, and their oxidation number is equal to their charge. Here the charge of sulfate ion is 2-, so its oxidation number is -2. More examples. Ammonium ion, polyatomic ion, its oxidation number is +1. Sulfite ion, its charge is 2-, so its oxidation number is also -2. Bicarbonate ion, its charge is only -1, so its oxidation number is also -1. Like this way, when any radicals are present in a compound, so its oxidation number of that polyatomic ion will be of their charge. Now we will follow some examples of oxidation number. Follow here. What we have known from the rules, the neutral element or elementary molecules, its oxidation number is always 0. Follow here. Hydrogen, chlorine, oxygen, ozone, they are elementary molecule, not compound molecule, so their oxidation number is 0. Now follow this. Here what we know, in a compound the sum of oxidation number is always 0. So from this equation we can easily identify the oxidation number of atoms. Follow here. Carbon monoxide, you know that oxygen generally use -2. So here one atom of oxygen is present and one atom of carbon is present. So if its oxidation number is -2, so to become 0, the oxidation number of carbon should be +2. But in this case, there carbon dioxide, here oxidation number is -2, but how many atoms are present here? 2 atoms. So if you multiply 2 this -2, then there will be -4. So to become 0, the oxidation number of carbon should be +4. So like this way we can easily identify the oxidation number of other atom. Follow here. Methane, you know that hydrogen when combined with non-metal, its oxidation number always +1. So here how many hydrogen atoms are present? 4 hydrogen atoms. So there will be +4, and to become 0, the oxidation number of carbon should be -4. So here the oxidation number of carbon is -4. Like this way, +1, -1. Zinc oxide -2, so zinc oxidation number will be +2. Also here these are peroxides, so oxidation number of oxygen will be -1. Here these are superoxide, so minus half. Like this way, water oxidation number, oxygen is -2 and hydrogen is +1, so +1 into 2 equal to +2, -2 equal to 0. My dear students, follow here. All are the examples of monoatomic or diatomic. Only these examples are follow here triatomic molecule. That means there are 3 different atoms are present. So in this type of example, if you know any 2 atoms oxidation number, then you can easily identify the oxidation number of third one. Follow here, this is potassium permanganate. You know that oxygen is -2, so for 4 atoms of oxygen, total oxidation number of oxygen will be -8, and potassium, you know that +1, so to become 0, manganese oxidation number of manganese should be +7. So like this way you can easily identify or calculate the oxidation number of unknown third atoms of a compound. Also you can determine through the calculation in a specific way. Follow the example. Follow here, the oxidation number of sulfur in sodium sulfate. So here sodium oxidation number of sodium is +1, and oxidation number of sulfur we should identify. For this we will consider it as X, and oxidation number of oxygen is -2. Now put here sodium +1 and 2 atoms of sodium, so multiply with 2 plus. We want to determine the oxidation number of sulfur, so we take it as X, and high oxidation number -2 and 4 atoms of oxygen multiply with -4, and the sum of them is equal to 0. So now through the calculation you easily understood the value of X is here +6. So the oxidation number of sulfur in sodium sulfate is +6. More example, perchloric acid. Here we know -2 of oxygen and hydrogen +1, but what will be the oxidation number of chlorine? So easily you can determine in this way. You let the oxidation number of chlorine is X, so when you through the calculation you will get the value of X is +7. So here the oxidation number of chlorine in perchloric acid is +7. And my dear students, oxidation number you have to always write with charge, plus or minus. Now more example, in H2O here the oxidation number of nitrogen is -1, but in N2H4 here the oxidation number of nitrogen is -2. So like this way I hope you can easily calculate the oxidation number of any atom in a compound. So I hope already you have achieved a clear conception about oxidation number. So let's start about the redox reaction. Redox reaction. This word redox, it has actually 2 parts, red, ox. This red part is taken from reduction and this ox part is taken from oxidation. So redox actually the short form of reduction and oxidation, these 2 parts. So what is oxidation and what is reduction? Actually redox reaction is a reaction in which this oxidation and reduction both are involved. Here oxidation means releasement of electron. Oxidation is loss of electrons. We know that in a reaction or most of the reaction there are present more than one reactant. So in one reactant if atom releases electron, so in other reactants that atoms are actually accepts electron. So the reactant in which releasement of electrons occur, that reaction is called oxidation half reaction, and the reactant in which acceptance of electrons occur, in that part of that reaction is called reduction half reaction. And the combination of oxidation and reduction, the combination of these two half reaction is actually redox reactions. So how can we define redox reactions? Redox reactions are those reactions which are involved in the oxidation and reduction reaction. And always oxidation and reduction occur together or simultaneously. They cannot exist alone. Yes, you can say when in many equation we have seen there is only one reactant. In that case, what is happened? Yes, you are right. In case of one reactant, there also occur oxidation reduction, both reactions. How? In that reactant, one atom of that reactant releases electron, that means oxidation occurs, and another atom of that reactant, similar reactant, there is occur reduction reaction, that means accept electrons. Like this way, both oxidation and reduction reaction occur in that of decomposition reaction, that means when only one reactant is present. We will see. Now, in oxidation and reduction reaction, actually these four matters are happen, that means loss or gain of oxygen, or loss or gain of hydrogen, or transfer of electrons, and changes in oxidation number. Especially in oxidation part, addition of oxygen is occur, or loss of hydrogen occur. In oxidation part, combination of substance with oxygen, that means addition of oxygen occur, or loss of hydrogen occur, or loss of electrons, that means in oxidation atoms releases electrons. And in oxidation part, always we will see the oxidation number is increased, and the opposite phenomenon occur in reduction reaction. So in reduction reaction, we will see removal of oxygen, or loss of oxygen from the substance, or gain of hydrogen, or gain of electrons, that means here electrons will be accepted, and decrease in oxidation number. And we will see in reduction part, oxidation number of atoms should be or will be decreased. Not only that, also in redox reaction you have to know about the oxidizing and reducing agent. So what is oxidizing and reducing agent? In a reaction, I have said, if there is present more than one reactant, then in one reactant oxidation occur, in another reactant reduction occur. So when in one reactant oxidation occur, then the other reactant which actually helps in that oxidation, that is oxidizing agent. Follow here, I have said in oxidation part, addition of oxygen is occur. So here follow this, hydrogen is converted into water. That means here with hydrogen, oxygen atom is added. So this is actually oxidation reaction. So in hydrogen, oxidation occur, and in presence of which reactant? Copper oxide. So here cupric oxide is actually oxidizing agent. And I have said reduction means removal of oxygen. So from when cupric oxide is converted into copper, so here which one is lost or which one is removed from cupric oxide? Oxygen. So this part is reduction reaction, and with in presence of what? Hydrogen reacted. So here hydrogen is reducing agent. That means the reactant in which oxidation occurs, so other reactant will be oxidizing agent, and which actually reduction is reaction occur. For this, the reducing agent is the species which undergoes oxidation. For example, here reduction is occur, so hydrogen is reducing agent, but hydrogen itself is oxidized, because when hydrogen converted into water, this is actually oxidation. So oxidizing agent helps in oxidation of other reactant but itself reduced, or reducing agent helps in reduction of other reactant but itself oxidized. I hope you clearly understand. Now follow the example. I have said oxidation reduction in terms of oxygen. Oxidation means gain of oxygen, reduction means loss of oxygen. Follow here. Here magnesium is after the reaction converted into magnesium oxide, that means gain of oxygen occur. So this part is oxidation, and here lead oxide is converted into lead, that means oxygen is removed from lead oxide. So this is reduction reaction. So reduction reaction, so magnesium is reducing agent, and here oxidation occurs, so lead oxide is oxidizing agent. Now follow more example. When cupric oxide reacts with hydrogen and converted into copper and water, so here this is oxidation part, addition of oxygen, and this is reduction part. So this is reducing agent, this is oxidizing agent. Here also hydrogen is converted into water, adding oxygen, so oxidation part. Phosphoric oxide is oxidizing agent, and here iron is produced with the removal of oxygen, so this is reduction part, and hydrogen is reducing agent. Like this way we can easily oxidation and reduction reaction identify, and also oxidizing agent and reducing agent we can easily find out from a reaction. Now in terms of transfer of electrons, in terms of hydrogen, so gain of hydrogen is actually reduction and loss of hydrogen is actually oxidation. Follow here. When hydrogen sulfide reacts with chlorine and converted into hydrogen chloride and sulfur, so in this reaction hydrogen sulfide is converted into sulfur, that means with the removal of hydrogen. So this is actually oxidation part, and this is oxidizing agent, chlorine is oxidizing agent, and here chlorine is converted into hydrogen chloride, that means gain of hydrogen. So this is reduction part, and hydrogen sulfide is reducing agent. Now in terms of electron transfer, this is a reaction copper ion when reacts with magnesium and converted into magnesium ion and copper. So in this case follow here, copper ion is converted into metallic copper, that means oxidation number is converted into +2 to 0. So here copper ion accepts 2 electrons and converted into metallic copper, so electron is accepted. So this part is reduction reaction, copper ion is reduced here, and magnesium is converted into magnesium 2+. We know that when any atom is converted into cation through the releasement of electron, so magnesium releases 2 electrons and converted into magnesium +2. So here magnesium is oxidized, magnesium atom is oxidized to a magnesium ion. Also follow here, combustion of methane. We know that combustion of methane, there are produced carbon dioxide and water vapor. So here at first you have to mention the oxidation number. Follow here, these are neutral elements, so this is 0. Here hydrogen +1, so how many? 4 + 4, so oxidation number of carbon will be -4. Here -4, so +4. Here -2, +1. Now we can see here carbon is converted into -4 to +4. So through the releasement of how many electrons? 8 electrons. How? Because at first it releases 4 electrons and converted into neutral carbon, and again releases 4 electrons and converted into +4. So total 8 electrons. Through the releasement of total 8 electrons, carbon is converted from -4 to +4. So here releasement of electron is occurred, that means this part is oxidation, and here oxygen it's converted from 0 to -2. That means oxygen releases accepts 2 electrons, then converted into -2. So acceptance of electrons occur. That means this is reduction, and total 4 atoms of oxygen accepts 8 electrons and converted into 2 and 2, 4 atom of oxide ion. So this is actually reduction reaction, and the oxidation number of hydrogen is unchanged. Here is +1, and here after the reaction there is also +1. This type of ion or atom is known as spectator ion or visitor ion. That means the ion whose oxidation number remain unchanged in a reaction, that ion is called spectator or visitor ion. Here hydrogen atom, 4 hydrogen atom remain unchanged at +1, so this hydrogen ion is actually visitor or spectator ion. Now in terms of oxidation number, when any equation or reaction we will get, at first we will see the oxidation number, and we know that in oxidation number is increased, and in reduction oxidation number is decreased. So here follow this. Here hydrogen, before the reaction oxidation number of hydrogen was 0, copper was +2, oxygen is -2, but after the reaction now oxidation number of copper is transferred into 0, hydrogen +1, oxygen -2. So here hydrogen is converted from 0 to +1. That means oxidation number is increased. So this is oxidation reaction. And copper from +2 converted into 0. That means oxidation number is decreased. So here reduction part is, this part is known as reduction reaction. And oxygen remain unchanged, -2, -2. So this is visitor ion or spectator ion. So like this way, through the increase or decrease of oxidation number, easily we can identify the oxidation and reduction reaction from a redox reaction. Now follow the more examples. Here chlorine 0, since it is neutral element, also hydrogen 0, but when it is formed hydrogen chloride, oxidation number is +1, -1. So 0 to chlorine 0 to -1, decrease of oxidation number, so it is reduction, and hydrogen 0 to +1, so it is increase of oxidation number, it is oxidation. So like this way, at first when you will write the oxidation number of correctly of all the atoms in a compound, then you can easily identify the oxidation reaction and reduction reaction. Now I have kept here one question. Oxidation and reduction occur simultaneously in a reaction, explain. This is very important question, because in every board exam you have to give answer at least one of this type of question. Each year this type of question come. So for this I have kept here this type of question, and also I have shown here the language of answer. So you will practice all equations using this language. When you will write answer, oxidation and reduction occur simultaneously in a reaction, explain. So in case of any equation you have to give the language, try to give the language like this way, then you will get full marks. So at first you will write the equation. If there is mentioned, then you have to write the required equation, then you have to balance the equation, then you have to write the oxidation number properly. If you write the oxidation number properly, then easily you can identify the oxidation or reduction reaction. So after writing the oxidation number, then you have to find out the oxidation or reduction part. Like this way, giving arrow, you have to write oxidation and reduction. Follow here, hydrogen oxidation number 0 to converted into +1, so oxidation occur, and oxygen oxidation number 0 to -2, so reduction reaction occur here. Now you have to also mention in an equation reducing agent and oxidizing agent. So after completing this equation like this way, then you have to give the language shortly. In the above reaction, hydrogen atom releases one electron to convert it into hydrogen ion. Always not at first you will write the total number of balanced atom. At first you just mention their oxidation number change of oxidation number 0 to plus 1. When hydrogen converted into 0 to plus 1 through the releases 1 electron, there is converted to plus 1, so through the releasement of 1 electron. So you have to write like this way. Then here oxygen atom is converted from 0 to minus 2 through the accepting of 2 electrons. Now when you will add these two equations, then you have to balance the electron number, atom number with the electron number. Follow here. Now adding the equation 1 and 2 with the balanced electron number, we will get the redox reaction by the following. Follow here. Here total atom 4 atoms of hydrogen and 2 atoms of oxygen is there. So to balance the electron number, 4 hydrogen atom releases 4 electrons converted into 4 hydrogen ion, and 2 atoms, we know that 1 atom of oxygen releases 2 electrons. So 2 atom of oxygen releases 4 electrons and converted into 2 oxide ion. So adding these two equations, electron will be cancelled, and like this way you have to pick out the equation again. So from the above discussion, we can say oxidation and reduction occur simultaneously in reaction. So my dear students, I hope you have a clear idea about redox reaction. So you will again thoroughly you will do this class, follow this lecture properly with a great attention. You can repeat it, no problem, but you have to acquire a clear idea about the redox reaction. This is very very important for your next life, also for your higher classes. So please you repeat and repeat this lecture, and you have to acquire about the clear idea about oxidation and also redox reaction. Today up to this, in next class I will discuss different types of redox reactions. So today up to this, goodbye.